Hello everyone. So after the last tutorial about using parameters, I now want to show you how you can make your objects conform to the landscape or to some static meshes that you have placed in your level. So you can project the items that you want on top of other things in your level. So let's start. Let's start first by looking at the example of placing these junkyard parts on top of our landscape. So I have this PCG graph, and you can see the area of the bounding box where we are placing this, and of course you can copy it and place it on other places and stuff like this, but it's randomizing the position based on points of our landscape and placing an object from a couple of different sets we have. So here are the three sets of objects that I'm placing, and the way that I separated them here, and it's not by type in a way, but in the way that they're placed in our level. So here, these four objects, let's browse to them and show you that if I place these objects, they're directly placed on the surface. So their pivot point is set at the bottom of the object. And it's the same for these ones, but I want this to be rotated to 90 degrees so they stay on their side, and that's why they're on separate set. And for these ones, they're having their pivot point in the middle, and that's why they will need to be moved. Because they need different positioning in order to sit well on our landscape, that's why I separated them in three sets. And let's start to look at the logic that we are using to place them. I'll select my PCG graph and open my graph here. Make the window a little bit bigger. So it's a relatively simple graph, but I'll start by disabling all of the static mesh spawners and show you how each part works and what it's doing. So first we are getting the landscape data. Let's get landscape data. Then we are using a surface sampler, and let's connect this to a debug node. So we are sampling some points on our surface, and of course, losing looseness of 1, we are randomizing the position. If we are having it at 0, it will look too uniform, so that's why we are using looseness of 1. The point extents is a little bit big right now. If I go to points per square meter of 1 or more, let's go 2, you can see that it doesn't really make any difference if I am at 1 or 2, because each point is 1 meter in its width and depth, and it can only place 1 point per each square meter. And it's again a uniform location like grid, because each square meter is just filled with 1 point, so it cannot do a randomization. And that's why we need to reduce the size of each point to something smaller, and this will allow us to have a little bit of randomization of the placement and also to have a bigger value of points per square meter. And in the case here, into my surface sampler that I used, I'm using 25 extents and 2.5 for our density. So you can see that it's a little bit too uniform. And that is why I want to randomize the position a little bit more with a transform points node. So let's change this debug to absolute value and make it a little bit smaller, like 0.1, so it's easier to see our positioning. And you can clearly see that it's too much of a grid right now. Just for our demonstration right now, we are using an absolute debug node with point scale of 0.1, so we can see a little bit better just the position and not the actual size. The actual size is the extents value, but we are just looking right now at the position. So in order to have a little bit more randomized position, I want to have transform points, and in our case it's this transform points. I'll copy it, and these transform points will move the points 5 meters into X and Y directions. And the problem with this is that you can see right here that when you move the points 5 meters away from their original position, they are no longer sitting on our landscape. And this is a problem if we want to have realistic result of our points conforming to the landscape. And this is where we are using this projection node, which is our tutorial showing right now. So the projection node, you can get it by dragging and doing a projection, and you need to have the projection target, and in our case it will be the landscape. So get landscape data again and connect it to the projection target. And now if we connect to our debug node, all of the points after our randomizing the position will be projected onto the landscape. So they will get the position from the landscape and the rotation from the landscape. So for example, the points that are right here, they will be rotated based on the normal of the landscape. So they will point a little bit up and right because the landscape is pointing into that direction. If you don't want this, select the projection node and remove project rotations. And now you will see that the points will have their original rotation. It will not be overwritten by our landscape. So you can see the points right here. They are not aligned with our landscape. If we check these project rotations, they are now aligned with our landscape. And this is a common place where people will get some problems when they use a static mesh spawner. Let's use our first static mesh spawner right here and enable it. Everything sits nicely on our landscape. And now we have the problem of everything overlapping. So that's why we'll use some self-pruning and we'll connect it right here. And now our objects no longer overlap with each other. We only have objects that are independent from each other. So this is the basic logic. So we can randomize the position and rotation and then project it back to our landscape. But in order to get some more interesting placement of our object, I'll show you some of the things that we are doing down here. So let's delete this example graph and let's start looking at the nodes right here. So this transform point is actually not doing anything. So let's connect directly here to the surface sampler, our other nodes. So we are using these collapse points right here in order to create some fewer but bigger points with this extents modifier. You can see that we are setting much bigger extents. So if I connect this surface sampler to a debug, let's again use this absolute and 0.2 value. So we have these points right here. And with these collapse points, we are getting these points and reducing them to just points that are 10 meters apart. So 1000 units is 10 meters apart. So it's much fewer number of points. So in our case, it's 16 points only. Let's make them a little bit bigger so you can see them. So these are the position of the points. And if we want to see their actual size, let's connect them to this extents modifier. We are modifying the extents. Let's change the debug to extents. So the original extents, if I disable this extents modifier by clicking the E key or right clicking and enable, and again uncheck for disabling. So this is the original size of these points, and with this extents modifier, I'm making them bigger. Then with this random choice, I'm selecting some amount of them, let's say 0.8 of them. So just some of them. Then with these transform points, we are scaling and rotating them into a random direction and random size. And this is what creates some gaps in our placement with this difference node. So by using our original points, then doing difference and connecting these fewer but bigger points to our difference pin right here. Of course, you need to change the mode right here to a binary in order to actually remove the points. So if I connect now this difference, you can see that we are cutting into the placement of our points onto our landscape. And this will create some more randomization and more realistic view of your distribution of points onto the landscape. So let's continue right here. So after we cut into some areas in order to not have such uniform position, now we are using this transform points from earlier that's moving the points 5 meters into X and Y directions, into random direction in X and Y. And let's add a rotation, 360, so random rotation as well. And then we are projecting it onto the landscape. So this is the thing that I showed you before. The same nodes projection with the get landscape data for the projection target. And right now, in order to choose which of the 3 sets I'm placing, I'm using these random choice filters. So here, this random choice will select between some of the points. So for example, 33% of the points will go to this first static mesh spawner. So let's delete these debugs and you can see that the first static mesh spawner is these 4 objects here. This tire, this chain, and this pan and container, fuel container. So for those points, I just have a random rotation connected. No movement or no placement changes. And this is the reason that they're in separate set. Because for the bottom set, I need to have, let's delete this extend modifier, we don't need it. So for the bottom set, coming from this disregarded point, so these are 66% of the points are coming here, and this random choice is then selecting half of the points going into our other set and half of the points to the bottom set as well. So these top ones, let's enable and disable them. So for these ones, I need to rotate them to the side, so 90 degrees to the side, and move them a couple of units, so let's say between 3 and 10 units. So they sit next to the surface of our landscape. So 10 is probably a bit too much for most of them. Let's do an 8. So now we have these objects sitting on our landscape as well. And this is why we need two separate static mesh spawners, because we are using the position that we generate of the point to spawn the mesh. And this is why if we need to place some of the objects on with another type of settings, we need to separate them into a different static mesh spawner. And the same is done for the last one. So as I showed you, we don't want to have these points. Let's enable this. So now that we have these random objects placed everywhere, I'm doing just an additional pass of placing some more objects around them. And how do we do this? We are taking the points that we are placing for our first type of object, and we are duplicating these points, and we are projecting them back into our landscape. And in this case, I connected this world ray hit query. So after we duplicate and transform the points again 5 meters to each direction to get a little bit more randomization, and I'm duplicating them 4 times. And in this case, I put this world ray hit query as the projection target. But it will not make any difference for our landscape currently. So let's change it to, again, get landscape data. And into the next example, I'll show you what's the difference. So here I'm projecting again these meshes back to our landscape. So if I disable the projection, you can see that the points are placed into the air because we are randomizing the position without knowing where our landscape is. And after this, we can project the points. So this chain right here is projected back onto the landscape and everything conforms well to our landscape. So after this, we are randomizing their rotation. We are self-proning them in order not to have stuff like this. So all of them just intersecting each other. And then we are doing a difference in places where the objects that we spawn right here are intersecting with our other objects that we already spawned from these three static mesh spawners. So we are getting this new set and making a difference with our already spawned objects connected here into the difference. And then we are spawning the same mesh as our first set without the tire, because I got too much tires anyway already. And this is basically the full graph. So the important thing for this tutorial is to understand that if you randomize the position of the point after you sample it from the landscape, you can no longer be sure that it's already placed on the surface of the landscape. So you need to reproject it again. If you are just randomizing the rotation, there's no need, but if you randomize the position as well, you need to project it back to the landscape with this projection node. So let's now look at our other example, which is here inside our building. So this is the other graph. It's a little bit more simple because I already showed you how you can work with these nodes, but I want to show you the world ray hit query node. The difference from before is that if we are projecting them into our landscape like this, you can see that they will be placed on the ground, but in places where we have, for example, these tables, these chairs, these radiators and stuff like this, they will go below them because our landscape is, of course, just at the bottom of this scene. But if we want to actually place them on top of objects, we need to create this world ray hit query node, and this node can be used as a projection target, and it will fire a line trace into your level and find where this line is intersecting with another object, and this will be based on the settings. So if you are using the default settings, which would be like this, so you are firing a line trace, but it's meeting this object here at the top. So in order to not have this problem, we can go into the data part of our settings and set the ray parameters by our own values, not have the default ones. And here you can control what is the height of our ray origin. So if I put the height, for example, of 50 meters, this will be way above our building right here. And when it projects into a ray direction of -1, and the ray length is 5,000 meters, so 5 kilometers, it will hit the object right here, our corridor objects from the outside. And in order to not have this problem, we can create the origin of the ray to be inside this room. So for example, 2 meters into the air. If it's just, for example, 20 centimeters away, it will be below our tables. So it will not hit the top of our tables. So we need to make it high enough to hit all the objects that we want, but not too high in order to be outside of the room. And the direction controls which is the direction that you fire these rays. So currently it's -1 into the Z direction. If I create it as 1 into the Z direction, you can see that in this way you can project objects on the ceiling. And for example, you can put these pipes or some cables or something like this on the ceiling in this way. But let's go back to -1. So we project the points on our floor and tables and chairs. So right now, if we go to our next transform points, it's adding some random position in order to place our objects to their sides. So if I disable and enable this, you can see we have some objects placed on our floor, on our tables right here, and this transform point is just moving them in order to not intersect the floor. I have all my objects here placed into the scene on our floor, tables, radiators. So you can see here at the radiator on top I have 2 objects, and it's adding a little bit of detail to our scene, and it doesn't require us to manually place everything. You can use this world ray hit query node in order to place objects on top of other objects in your scene with the projection node. Another consideration would be the setting of what channel is your projection using in order to select the object that you are hitting. The tables that we created here have some setting for them for their collision. So let's go to collision, and you can see that they're using the default value, but in our case this is like setting them to block all. And this block all, you can see that this object type is world static. So let's go back to the default, but again this default is block all. So this world static channel means that in the graph that you are projecting your objects with this world ray hit query, you need to make sure that you go into the advanced data and the collision channel is set to world static, because if it's world dynamic, you can see that the collision is not happening because these objects are with static collision. And if it was the other case, so for example, if I go into this table object and I change this collision preset from default into block all dynamic, and now if I regenerate my graph, these objects no longer go to the table because it's not having this static channel which we are searching here. But if I change it to a world dynamic, now it's properly placing the objects on top of this table. But everything else which is static is not working. So make sure that all the objects that you want to use as this projection target are having the same collision channel, and that this collision channel is set properly into your world rate hit query. The other important thing here is to look at this select landscape hits for this world ray hit query. So in this case, we have this include value, and this means that if I move this here to the side, you can see that we are projecting onto the landscape, but we are also projecting onto our tables. So let's move the tables again and regen. So we are projecting onto the landscape and onto the objects. And you can use this select landscape hits drop down to select the behavior that you want. So for example, I can exclude the landscape hits. I can only include hits that are on some static meshes. Or I can require the landscape hits. In that case, it means that it will only work with landscape hit queries. So it will not work with static meshes. So if you want to include everything, just leave the default value as include. And you can of course use other filters, like for example, I want this table to be, let's add a tag. And this table will have an actor tag of no projection. And let's go right here. Let's create an actor tag filter, exclude, and the tag list will be no projection. And right now you can see that this table that has this tag of no projection is not capturing our objects when we are doing this world ray hit query. If we change the value to require, now only objects with this tag will have these objects projected onto them. And this as well valid for creating splines in your level. For example, here, if I create a spline, let's go to our modeling mode. Let's draw a spline. And let's add some tag to this spline, for example, test. So if we go back right now, let's create another PCG graph. Let's create an empty graph, test PCG. So this test PCG will get actor data. We will get overrode actors, and they will be by tag, and the tag will be test, just the tag that we created right here for our spline. And this get actor data will get our spline. Let's do a spline sampler. Let's do distance and 200, so each 2 meters. Let's place some object from our barrels that we have here. So I'll copy the static mesh spawner. So like this. So this point currently, because I drew it in the level with our modeling tools, is following the surface of our landscape. But if I want to change the shape of this point, it no longer is conformed by the surface of our landscape. There is no connection between the spline and the surface of our landscape. And that's why if you are creating points with splines and you want them to be sitting on the landscape, you can again use this projection node, get landscape data, and project them onto the landscape that way. So right now, no matter how high or low or side to side my spline is, all of the objects will be placed on our landscape. And you can use this for fences or anything that you create with splines. And of course, if your spline is actually a closed loop spline, for example, let's search for closed and mark the closed loop. And now let's go back to our PCG, change the spline sampler to not be on spline but on interior. So it will spawn objects inside of your area of your spline, like this. For example, so if you don't have this projection, so let's disable it, all of the points will be right here. So just a flat surface between your spline points. But if you project them, then you can use this spline to draw area on your landscape and to be sure that all of the objects that you place inside are into this area. So guys, I hope this clears up how to work with projection node, with the landscape, and also with different static meshes, and what are the general pitfalls and recommended settings that you need to change. If you like this video, please like and subscribe for the channel. If you want to watch these videos earlier than everyone else, ask your questions earlier, you can join the channel into the higher levels. You'll have a week advantage of watching the videos earlier, and in that way you'll get your answers in the comments answer quicker. Hope this helps, and I'll see you in the next video. Bye guys.